Hello everyone, welcome to our group. First of all, allow me to introduce ourselves. I am Joanel James and my group consists of Noor Hanisa, Zabora and Nawashri. First of all, let's talk about the problem that we are facing today in school. Malaysia's rising heat levels are increasingly affecting the comfort and focus of students in schools, creating challenging learning environments. Unfortunately, many schools are unable to install traditional air conditioning systems due to high costs involved in installation, electricity consumption, and ongoing maintenance. Additionally, conventional cooling systems may lead to health concerns such as respiratory issues and dry skins. But who is this all affecting? Students, school staffs, and teachers are getting affected by this. Well, but what are the current solutions for this? Well, the current solutions are fans, air coolers, and air conditioner. But there are so many disadvantages of traditional air coolers, such as it causes health issues, it's high maintenance, it consumes very high electricity, and it's a noise pollution. Well, are you exhausted of being hot at school? Of course. That is why we came up with Smart Coolers. Smart Coolers is an innovative, eco-friendly and affordable cooling system that uses rainwater and natural processes to regulate classroom temperatures. It is a sustainable cooling system that combines science and engineering principles to create a comfortable and healthy learning environment with low environmental impact. Smart Coolers relate to many SDGs. First of all, SDG number 3, good health and well-being. Smart Coolers reduces risk of heat exhaustion, rashes, and respiratory issues in students and teachers. It also creates a healthier and more comfortable learning environment. Next is SDG number 4, quality education. Smart Cooler provides comfortable classrooms, meaning better focus, concentration, and learning outcomes. Next is SDG number 6, clean water and sanitation. Smart Coolers uses rainwater harvesting and promotes the safe use of water resources. Plus, we are using flush diverters and sealed tanks. This ensures the water is clean and safe at all times. Lastly, SDG number 7, affordable and clean energy. Smart Coolers uses minimal electricity compared to air conditioners. It works as a low-energy cooling solution, which can be powered by solar panels. But how does Smart Coolers work? Well, rainwater is collected from rooftops using gutters and downspouts. The first flow of rain, which may contain dirt or debris, is discarded using a flush diverter system, ensuring cleaner water is stored. The rainwater is then filtered and stored in sealed reservoirs installed in the ceiling of classrooms. This step prevents contamination and minimizes health risk relating to topics in biology. The stored water circulates through pipes embedded in classroom ceilings or walls. This system is called a closed-loop cooling circuit. As the water flows, it absorbs heat from the surrounding air, reducing room temperature. The now warm water is sent to an underground aquifer tank, where it is naturally cooled by the stable temperature of the soil. This natural cooling process conserves energy. The cooled water is pumped back into the system to continue absorbing heat, creating a reusable cooling cycle. This efficient system greatly reduces the need for electricity and artificial cooling systems. This is our AI-generated design of Smart Coolers. There are so many benefits of Smart Coolers. First of all, environmental impact. Smart Coolers uses rainwater, it's eco-friendly, and it promotes sustainability. Next, economic impact. It's cost-efficient, long-term savings, and it's low maintenance. Next is comfort. Smart Coolers lowers room temperature, enhances focus, and it's a quiet operation. Next is health and safety. Smart coolers has no health risk, no dust or bacteria, plus it's natural cooling. How did we come up with smart coolers? We began by identifying the problem. Many Malaysian schools lack affordable cooling systems. Students and teachers suffer from heat-related issues affecting comfort, health, and academic performance. Air conditioners are costly, consume high electricity, and may cause health problems. Therefore, we conducted a review of existing cooling systems, sustainable architecture methods, and passive cooling techniques. Next, we designed the smart coolers prototype. The key design components are gutters and downspout systems for rainwater collection, flush diverters to remove contaminants, filtration unit for cleaner water storage, ceiling-mounted water reservoirs, closed-loop piping circuit for heat absorption. Lastly, underground aquifer-style cooling tank. Our aim is to provide a more comfortable, healthier, and energy-efficient cooling method for schools across Malaysia. By using natural resources and smart design, this solution not only reduces environmental impact but also makes it possible for more schools to offer better learning conditions despite budget limitation. The conclusion and impact to the community is that smart coolers offer a cost-effective, low-risk and sustainable alternative to traditional cooling systems. The benefits extend beyond comfort. They promote better health, greater focus and energy efficiency. And plus, it's more conducive learning environment for students and teachers across Malaysia, especially in the face of escalating climate changes. It is also a step towards creating healthier, greener, and more resilient schools for future generations. It combines innovation with simplicity, affordability with impact, and comfort with the care for the environment and community. As Malaysia moves towards a more sustainable future, solutions like smart coolers will play a vital role in ensuring that all students, regardless of background, can learn in a safe, cool, and inspiring environment. That is all from us. Thank you.